Hi everyone. Today I'll look at a kind of question called building redox tables. This is a style of question that's going to ask us implicitly to apply what we know about spontaneity and what we know about the format of the table of reduction half reactions in the data booklet to build our own. We're going to be given 2 or 3 or sometimes even 4 reactions and told whether they're spontaneous or not. What we're going to do is use our 2 spontaneity rules and what we know about the data booklet. Remember, the data booklet, the format of that page in the data booklet is reduction half reactions, where the oxidizing agents are on the left-hand side, with the strongest oxidizing agent at the top, and they get weaker and weaker as we go down. We want to construct that style of table. Chemicals in these questions are often going to be made-up chemicals, A, B's, and C's, or chemicals that aren't specifically listed in the data booklet. So, our first step is to take the reactions one at a time. Our first step is to decide which chemical is the oxidizing agent, which chemical is the reducing agent. Here, I have to look really closely. These A positive ions became A solid. How did that happen? By gaining electrons. These A positive ions gain electrons, get reduced to become A atoms. If they're getting reduced, that means they're the oxidizing agent. By a process of elimination, the B must be the reducing agent. I can reflect more deeply about it. It was neutral, B atoms, that became positively charged by losing electrons, by getting oxidized. The substance that gets oxidized is the reducing agent. After we decide which chemical is which one is the OA and which one is the RA, then we can apply what we know about spontaneity to put them in some kind of order. This reaction, I'm being told, is spontaneous. Because it is spontaneous, the oxidizing agent is going to be higher than the reducing agent. This means that A, the oxidizing agent, is higher than B in the table that we're going to build. This says that A is higher than B. That's all I'm doing. I'm not putting down any kinds of half reactions yet. I'm not worried about whether there's a charge or not. It's just that A is higher than B. It's the oxidizing agent, A, is higher than the reducing agent, B. Now, I follow the exact same process for the second reaction, beginning with which chemical is which. Here I, again, have A positive ions becoming A solid. Just like the last example, the A is the oxidizing agent, and now by a process of elimination, C is the reducing agent, and it was neutral, it became positive by losing electrons, by getting oxidized, it's the reducing agent. I am being told that this reaction is non-spontaneous. If it's non-spontaneous, the oxidizing agent is below the reducing agent in our table. So this means that A, the oxidizing agent, is lower than C. So where am I going to put C? Below the B, in between them both, or up at the top? Up at the top. The first reaction, because it is spontaneous, means that A is higher than B. But the second reaction, because the oxidizing agent A gives us a non-spontaneous reaction, it has to be below C. So we end up with this order. Once we've decided on the order, we need to turn these into reduction half reactions. The oxidizing agent has to be on the left-hand side because they are going to get reduced. So I know that we have C here as a reactant, regular C, and the C ions are over there, but because we're building a table of reduction half reactions, we need to put these C ions there. And the A ions and the B ions. I had to look really closely at the reactions that were given to me to find the charge. Here's the C2 plus, A had a 1 positive charge, and B had a 2 plus. I had to pull that information and get them in order. Now they're going to be gaining electrons, they're getting reduced. The number of electrons gained is going to match the charge. 2 positive, so the C gains 2 electrons. To become C solid. The A was only 1 plus, it's only going to gain 1 electron to become a solid. The B is also 2 plus, similar to the C, it's going to gain 2 electrons. To produce B solid. I've created a table, a redox table, that follows the same format as what's in the data booklet. Oxidizing agents on the left-hand side, with the strongest oxidizing agent happens to be C2 plus at the top, and they get weaker and weaker as we go down. The weakest oxidizing agent here are these B2 plus ions. They're undergoing reduction, they're all gaining electrons to form metal atoms. And again, they're in order with the weakest reducing agent at the top and the strongest reducing agent at the bottom. I can double check to look at my original question to see if I'm right. The first one says A is higher than B, A is higher than B. In the second reaction, the A plus ions must be below the C solid. Here's the A plus ions below the C solid. We've built a redox table. And I hope that helps.